Welcome everybody. Talk about JavaScript. How you doing tonight?
Good.
Good. Good. All right, everybody get something to eat. All right. Looks like we're find a seat. I'll let the space and the food is all provided by West Toronto partners. Give them a hand. And Chris, you wanna tell us why you're doing that?
Yeah, thanks so much. Thank you all for coming. So just to give you a brief overview of West Monroe, if you've never heard of us, we are a full-service consulting firm, do a lot of business technology consulting, do pretty much everything, front-end, back-end, web, mobile, everything you can think of, and always hiring. As far as a couple of housekeeping items, if you need Wi-Fi, our password is up there. Not sure if you can read it, but it's GoWest_guests, and the password is WMPGoWest. Thanks, Ben. And please finish all the pizza and help yourself to the drinks in the bathroom right over here. Thanks.
Thank you. All right. And now for the main event.
Thank you.
John
Yeah,
Vall and
of course.
Redux.
We have like half of that pizza still left, so there is plenty left over. I will not be offended if you leave early to go take some of that. So first of all, it's great to see some familiar faces. Some of you were here last month when I presented on Rxjs, and apparently Giancarlo thought I was like okay enough to come back a second time, so I'm really pleased to be presenting again. And one of the other things too is that I'm really thrilled to be on my home turf here. I work for West Monroe. I've been here for about 3 years. Come chat with us about the company if you're looking for a job or would like to learn more about us. Chris, Lee, Jason, Greg, and the little logo there. We'd be happy to talk to you. So Redux, I called this the talk that every front-end developer needs to know because it's just blown up. I guess the software pattern is blown up in the React world, and it's picking up steam in Angular. You know, like one of the big focuses at NGConf this year was NGRX, which is Angular's official implementation of Redux. So it's a very important pattern. The past project I've been on the past year with those two in the back, I'm in the middle row, they've been on my team. Redux, it wouldn't have been possible, but I feel like the project would have been very, very difficult without Redux. I'll show you why in a second. What is Redux? Well, you can read tons of different guides. You can read about the philosophy of Redux. But essentially, it's a very scalable way to manage state in your app. What do I mean? What kind of state? You can tell your app what kind of routes that created, what UI elements selected, are you logged in or not, and then you can also tell your app transactional things, like are we currently processing search query? Do we need to show a loading script somewhere? These are all of the kind of questions you can answer with Redux. Any kind of object you can throw into the Redux store. And if you're familiar with either Angular or React, Angular being new Angular, not old Angular, I think you'll find yourself pretty familiar with the concept I'm talking about. If you're not, you might be a little lost. I can help you catch you up later. If you're totally lost, well, I guess we're going to cover in this topic the why. And I think this is important whenever you're talking about a new technology is to first discuss even the why before you use it. I mean, who's, just curious, who's new to web development here? Like new-ish? Oh, you've got quite a few. There's this thing like JavaScript fatigue, and if you want to know what we're talking about by that, open the node module folder one time and look at the side of that thing. You'll quickly understand why like JavaScript fatigue is a thing. And sometimes it might feel like whenever we talk about a new library or a new framework or a new pattern, it might just feel like it's reinventing the wheel of stuff that's already been there. I don't want you to think that about Redux. This is really revolutionary and a pattern I think that every front-end developer needs to know. So I want to cover the why, like the problem of what to solve. And then we'll go into a case study, a very real-world problem that we solve with Redux. We'll jump into the fundamentals and then we'll jump into a code demo. I tend to talk pretty quickly, and I'm talking about 45 minutes, so feel free to like interrupt me at any point with a question. So here's kind of what the issue is. You have a component tree, and this could represent hundreds of different components in your application, or a subtree, or whatever. You might have your app component at the top and have all, whatever. Like this is a huge application, right? And you have a component that initiates a change, okay? And then unidirectional data flow, we have the parent component that has some kind of change, and then it binds those changes down the component tree, right? And those children component update their state accordingly. If you have a child component that initiates this change, well, it can't really bind state changes directly back up. It's all unidirectional, and I won't speak to the virtues of that, but if you think Angular or React, what it will do is it will fire some kind of an event, it will call the function, it will tell the parent, here's this event, here's this change, and here's maybe some data associated with that. I'm going to let you do with what you want to do with that, essentially. And then the parent can say, okay, I'll take that change and then bind properties back down. Simple component, unidirectional state change work. Now to throw a monkey wrench into this whole thing. Let's say you need to take this change and then bind it to a component way over here. Like you're working on a dashboard, and click log out way over here, and then your login component is way over here. So how do you communicate that piece of state change from here all the way over here? And the answer is really not easy. What you have to do is that you have to fire an event from this component, then you have to fire an event to the app component, then you need to bind state change down, then down, eventually making your way down the state tree. Furthermore, let's say now this component, based on the state change, has another event that it needs to fire. So how do you communicate it to this component that needs to know about it? Well, then you need to fire another event up to the app component and then down the tree. And before you know it, you have a spaghetti mess of events and component property boundaries, right? You might have like hundreds of these in the application. So Angular does something. It has services to manage this, okay? So if your components need to access pieces of state on demand, because usually services in Angular are singletons that might be registered at the module level or the application level, you can inject them. So, in your app component, maybe it needs to know about users, and then you can inject a user service and those components need to know about that state. But then, let's say some other components need to know about photos, for instance, so then you inject the photo service. Other components need to know about the metric service, you inject the metric service into it. And before you know, this approach is kind of cumbersome too. If you have like 50 or 100 different domain objects in an application, this can kind of get cumbersome, creating 50 or 100 services for each of these different domain models, right? So back to the original problem. You got this component, these two other components need to know about this piece of state change. So what Redux does is that it has a centralized store that feeds this data directly to all parts of the component tree. And I know what you're thinking is that might trigger, a thought in your head that might be like, this is wrong. I think developers were taught like putting all of your eggs into one basket is necessarily not a wise architectural decision. But this is what Redux is. It's putting all of the important centralized application state into a centralized store. So what that looks like is that instead, this component will fire a change, it will dispatch an action, but instead of going to the parent component, it will go up to this store, which is kind of like a local database, right? And then it will just feed that information to the components that are interested in it. No spaghetti mess of events and property bindings that you have to deal with. Super scalable, very nice. And then you can get that update to the component that needs it. So that covers the why. And let me tell you of a real use case we use this for. So I apologize. If you were at their Rxjs talk a month ago, you heard about the same project, same client. It's a big deal to me because it's been kind of like my bread and butter for the past almost year now. I've been on this project. But anyway, we were tasked by a client to help them develop this restaurant software. And the reason I'm using vague language right here is because I'm not actually allowed to share the client name, nor am I allowed to share a live demo of the code, or otherwise I could get in trouble with the lawyers. But you can probably Google a lot of these keywords and figure out who this is. But anyway, I'm not allowed to say it. But kind of the idea is that this client provides software to restaurants. I mean, think PF chains, think Jimmy John's. This is going in all over the restaurants you order lunch from every day. And the thought is like you have these workflows. So you get into work one day, maybe you're a corporate admin, a manager, or just regular shift worker. If you've been in the restaurant industry or you're currently working right there, there's a lot of tasks you need to complete in the morning. So you get there, you might have to clean the patio, you might have to heat up the chicken, you might have to count inventory, you might have to turn on the window, open the sun, common tasks every day that people in the restaurant industry are tasked with. Like the idea of this software is it helps you keep track of these workflows, right? And if you've ever worked in the restaurant industry or have or currently do, you'll know that it can be very chaotic. There's lots of different interactions per minute. It needs to be highly interactive. You have different components, that users are touching over here, and different components that are responding to that. And in our application, for instance, we have hundreds. We literally have hundreds of these components, in our source code. So communicating state change from one component to the other would have been a massive headache if it weren't for Redux. So I'm going to give you this is an actual screenshot, so this is what I was able to share. So you've got your workflow on the left, and we currently have morning checklist selected. So this is a checklist someone who's coming in at 6 a.m. would have to complete. So who's the morning manager? Did you unlock the front door? Did you turn off the lights? Are all the tables set? Did you not set the tables? What was the reason for that? Let's trigger a follow-up based on that. And you can also see here, as you complete these items, the workflow item gets shaded green. And what you can also see is that this little loading spinner over here kind of increments. It kind of grows as you complete this morning checklist. And between this component and this component, I guarantee you there's probably 20 or 30 parent components. There's a lot. So Redux was a very natural choice because it provided a centralized store, and these two components that were interested in completion state could subscribe to. All right, that's kind of the problem that was solved. So hopefully I've laid out the reason or the why. Just large application, lots of state changes, very interactive dashboard kind of thing going on. This is what it's made for. Let's start with the store. So we have a store. It's like a database. It stores everything centrally in your application. So going back to the photo, it's up here, and then different components can subscribe to changes in the store, select things, much like a database. That's really all this is. It's just a centralized database. And remember, I mean, your initial thought might be to panic when you're thinking like, okay, put all of your state in your application, your application state into one kind of centralized, like eggs in one basket. But it's encouraged in Redux. And remember, you can still keep local component state. You shouldn't throw like hundreds of different things into like the central application state. There's really items of interest in the whole application, right? Things that can't be derived, things that come from the database. It isn't all just one free-form object, okay? You can segment it based on domain models. We have user profiles, photos, friends, whatever. If you're using TypeScript, it also kind of helps with type checking on this. So just a consideration. But once you have that centralized store, you then have actions. So actions are the things that represent changes in the application state. So let me show you an example. So I kind of lied. A component never changes state directly. What it does is it dispatches an action. Okay. What does an action look like? It can be log user in, comment and post. Like any of these things could be actions. Two things about actions: they're uniquely named. Okay. Typically, like actions are just strings. They're just strings that have to be unique throughout your whole application, like log user in, comment on post, fetch profile success, whatever. They're just typically strings or enums if you want to do some more type checking TypeScript. And then the second thing is that they may or may not have a payload. So, what do I mean by payload? Think about log user in. So this is an action that's kicking off like an authentication flow. Probably not going to have a payload. But think about this. Comment on post. What would the payload be? It might be the ID of the post you're commenting on and then the actual body of the comment. That might be included in the payload. I mentioned at the beginning that there's kind of transactional things. So fetch profile success. So we had an existing action that had like fetch profiles. Now we needed to communicate the success. What does the success action look like? The payload is just going to be the array of profiles that we fetched. Error. Let's say that HTTP request failed. Your payload would be probably the error code, like a 401, 500, whatever, and then the message of the error. Okay. So you may or may not include a payload with that action. Now that we have a store, we have an action that describes all the actions that we could apply in your application. Now we need something to take those actions and apply those changes to state, and that's done through reducers. Okay, so reducers are essentially like these functions. It's really just a function. They kind of act like a function. You define like a switch statement with all of your actions for that domain. I'll say like favorites reducer or comments reducer or whatever. And then based on that switch statement, you apply the change to state. Okay, just acting like a funnel. And I figured it's more helpful to show you a code sample here. This isn't like too hard to do. Up here we configure initial state. So like when the app bootstraps right here, we're going to have an empty array of comments and an empty array of likes. And we have our actual reducer, which is just a simple function. It's taking its state, like the existing state that exists in the store that the framework is calling every time a state change is made, and then an action associated with that. And then we're also using this like initialization like syntax. So like if state's undefined, meaning at app bootstrap, we're going to initialize it with initial state. So I didn't include like every single action intentionally, but let's look at a sample one. We switch, and let's say we get a post comment success. So this, this comment got posted in the API, and we got our 200. We got a green light. We're ready to go. We're now ready to reflect that in the application. So what we'll do is we'll return a new object with all of the existing state, and then for comments, we're going to concat what was existing there, and then we'll concat that with a new array, and the single element is the payload. That is the comment that just got posted. This is kind of curious. Like, why am I not making state changes directly? You might be wondering. I'm going to comment that in a second. But this is kind of how it looks like. This is just a simple function. That's all it is. I want to cover some like important rules when writing your reducers. First of all, it's unidirectional, like components. You're not making state changes up the tree. Reducers should be pure functions and derive new state entirely off of their parameters. So you don't want to introduce side effects. You don't want to introduce like HTTP calls. You don't want to call or initialize new dates or new moment objects. Nothing that can be predicted from the parameters you want to put in your reducers. I'm going to cover the one in a second. Another important principle: state must never be modified directly, so it's always derived. Do you know why it's called a reducer, by the way? It's named after the JavaScript function reduce. The idea you have this accumulating state over time, and you're making an incremental change. That's where it takes the name from. But you're never modifying this accumulated state directly. It's just always, it's a new object derived based off of the old object. And finally, reducers match entities or domain models. It's just kind of, you're reflecting your data layer. Mostly, you don't want to be too specific down to the component level. Just reflecting your data layer, pretty much. So why am I harping on all of these rules? You're avoiding bugs doing this. Think if you're modifying state directly, you could introduce all sorts of race conditions. If you let the framework handle that, it's It's going to coordinate things for you very nicely, and you're not going to end up with this race condition like component 1 versus component 2 fighting over this field, and now suddenly you're having a really tough time. You're spending hours debugging this issue. Just let the framework handle state changes. So that's a very important thing to keep in mind. The second thing, undo and redo is easy. Think about like if you're editing like a word processor or workflow software like VR. If you keep state and very incremental changes through a reducer, it's very easy to undo that, right? Because it's a pure function, right? So it's almost like the inverse, like if you need to undo, or like the inverse of the inverse if you need to redo. That's very easy. If you introduce like a moment object or a creation of a new date, that introduces some unpredictability that's going to affect not only your unit testing, but kind of your undo and redo functionality. And also the other thing too is that historical debugging is easy. I'm going to show you a browser tool in a second that goes like step by step. You can see your application state at any point in history and revert back to it so you can see state changes. So debugging is almost amazing. The final part of this, so we have our store, we have our actions, and then we have our reducers that kind of combine the two. Is this making sense so far? Like any questions about this? Pretty straightforward. So the other thing too is that about async actions and HTTP calls. So where does that fit into the whole picture? Because we're calling APIs all the time, and you might be surprised. Redux doesn't have an opinion about this officially, and I'm not like a big philosophy person. Like I don't know, like you can read about all the philosophy behind Redux and whatnot, but at its core, Redux tackles state management. Like it doesn't really say much about async data. So you can kind of process these things through what they call like an effect or a side effect, and there are many libraries that do this. Like React, you've got Redux Thumb, Redux Saga, Movex. Redux Observable is what we used for that workflow project, and that worked out very well for us. And like most of us came from an Angular background, we were used to using Rxjs, so this was a very natural fit. But you have your options in React. In Angular, NGRX is the official Redux implementation, and it does provide an effects module for you to use, and it's all observable based. So like if you use the framework for any amount of time, you can fill it. This is how it typically works. A component fires an action, like fetch profiles. Your library is going to pick up on that. So like with observables, you're just subscribing to the library. You're subscribing, and like the observable fires fetch profiles action, and it's going to pick up on that change, and your HTTP request is going to fire, and then two things will happen. The side effect will then fire a subsequent event. It's either going to be a successful event, meaning like I fetched the profile successfully, here's your payload of profiles, or it's going to fire an error. Like if it's 500, you're going to get a payload with like a code of 500 and then a message, right? So two actions, and then your components. Like let's say this was an error, it could fire out like an error toast or an error message or something like that based off the Here's kind of like the TLDR. So like, basically what I described is like the whole like fundamentals of this flow. So component dispatches an action. The side effect picks up on it. It performs an HTTP request, and then if it's a success or an error, it's going to then dispatch a further action. It's going to get funneled through the reducer. The reducer is going to apply those changes to state, and then that state in the store is going to be reflected back in the components. I know these are like crappy like Microsoft Office drawings, but if you wanted like the TLDR, like the overflow, or like the overview of this presentation, this is the image right here. There's side effects that respond to certain events. Your reducer might respond to other different types of actions, and then it all gets funneled through your reducer back into store and back to your endpoints. That's just the full flow of this. I'll send a link to this whole presentation. How the store is set up in a project. Glad you asked. That's coming up. It's like you're in my mind. I guess it's right here. So I'm going to pull up a demo. By the way, have any of you started to use Firefox again? Yeah. The newest release, Quantum, people can't believe I use Firefox, it's sort of Chrome, but the new debugger tools are really nice. Firefox put a lot of effort into the latest release. It's worth checking out. I have no idea. Oh, if you run a node program, you can plug it on. I have no idea, actually. So the lie is, I keep my clients' session information on Chrome and debug personal stuff on Firefox. I kind of keep the sessions separate that way. And I've always been able to debug we're developing our microservices with Node, and it makes it really nice in Chrome. I've never done it on Firefox. Maybe it doesn't work. Yeah. That's a good question. I kind of want to test that up. Here's an Angular app. Let me show you what this does actually. Have you used Stackflix before? It's kind of a cool idea. So I kind of developed this, or not developed, I kind of hacked together this Spotify sample application last minute. But I'm gonna authenticate. Darn. Oh, wait a minute. I think I'm still on here. No. Don't mind me while I just log into my personal Facebook. Okay. So I'm authenticating through Spotify, essentially. Get access to the API. And what this is, you'll have to forgive me, the UI isn't really polished on this thing. It's kind of crappy. I just imported a bunch of Angular material components and kind of hexed them together. But the idea behind this application, you search for songs and you add it to your favorites library and then play them. So if I search for a song, no problem, and then in the background it's kicking off this HTTP request, and I get all sorts of songs that match that. I can favorite them. I can favorite them. I can go, oh, thank you, yeah. Not bad. Material makes it easy to throw these things. Yeah, but you can see, as I'm searching for them, I'm clicking favorites, and then I can even play them. Hope this isn't this is all using the Spotify API. What was that? So that's kind of the idea behind this application, right? Just searching the Spotify API for song. So let's, gentleman in the back or in the middle had a question about how store is set up. Let's dive into the code. So I'm using NGRX, which is Angular's official implementation of Redux. So let's go into our reducer. So right here I have some application state, and I'm defining the interface for this. So really, all of the application state in the simple sign is an array of songs. So I have search results and favorites. That's really the only two pieces of state I needed for that whole thing, right? Isn't just song. Scrolling down. I have a list of actions, and son action types. It's just an enum with some strings in it. But I'm saying okay, on a search success, what I want to do is take the existing state. I'm using my spread operator to kind of put all the properties or the object references in a new object. And then what I'm also doing too is that instead of keeping the old search results, I'm replacing it with the actions payload. So there's an effect in this library that is responding with a search song success with a payload of all the songs that match that query, right? And then I can favorite songs. So I actually don't have an API for this. Favoriting is just all local. So when you click the favorite button, it dispatches a favorite song. The action payload is the ID of the song that I want to favorite. And what this is doing is it's taking from the search results the song I want to favorite and then concatenating it with the list of existing favorites. Remember, I'm never modifying state directly here. I'm always kind of computing new state based off of the old stuff. So that's our reducer. Let's take a look at our effect, all right? So if you don't know Rxjs, this might be kind of like a mystery code, but essentially what this is doing is taking a list of actions right here, and then I'm using the pipe operator, and then what I'm saying is, okay, if any of these actions match search song, so, you know, the search component is firing off the search song, and it has a payload. The action payload is the search query. It's then going to fire off to the search service an HTTP request to the Spotify API. And then once it gets that result, it's then going to map it into a success. I didn't do a catch statement to catch the errors, but in like a real application, you want to catch the errors and display like a toast or something like that if it failed. But yeah, so in our search service, well, actually, I can tell you what, let's go to the So right here, you know, like, here's kind of like our search, right? So on search input, what I want to do is take the input text, and kind of what I do right here, the cool thing with Rxjs is that I can filter out empty queries. I don't want to search the API if I have an empty query. What I also want to do is give the user some time to complete their search query. I don't want to keep firing HTTP requests for every single keystroke, so I added a bounce time. And then finally what I did is that I added a distinct chain. So don't fire an HTTP request unless I have a distinct result, unless it was different from the last one, okay? And then once I get those results, what I'm going to do is I'll dispatch, so like the search query is unique. It's been like about a second, 1,000 milliseconds since the user last entered the character. I then want to subscribe to that and then dispatch a search. So what will happen is that the effect will pick up on search songs. It will search. Let's jump into the services. What will happen is that it will query Spotify's API right here. I have an interceptor that's attaching the token. From that authentication flow you saw with Facebook earlier, it's attaching a token to this HTTP request that's configured at the module level. Not super important, but I'm gonna search this query. It's of type track, and then I'm gonna map it to a song. And then the reducer will pick up on that, it will concat that, it will replace the search results wholesale, and then, you know, I might have a favorite action dispatched right here. So this action is tied to the favorite button. I'll dispatch a favorite song, and this would go back to the reducer. Remember, favoriting is all local. We don't need to so the reducer just puts stuff on it and just concats it. And that's all there is to it. By the way, another cool thing. I mentioned like you can do historical debugging in this. let's say for school. So there's actually a plugin for Firefox and Chrome DevTools. I need to refresh the page. It's going to show you all of the actions that are fired off. So watch. No. So right now, I search songs right now. Like after the observable, it filtered out like all non-unique results after a second, and then fired off the search results, and then I got a payload back. So you can kind of see the action right here. It's just type sing or search song. There's really nothing else to it. But then when I have a success action, this is what the payload looked like. So this was all the results from the API. And look, the other cool thing about this is you can look at the diff. You can see exactly what point in time things change. So between these two effects, like the app initialization and the search, nothing changed. But what I'm going to do is I'm going to go to success. This is where things change right here. In like green means additional state, right? So pretty cool. Like, and I can just revert. I have all these buttons like reset state and this is very precise debugging. Let's favorite a song. So I'm going to click favorite. What happens? My diff is going to show that I added the favorites to the favorite array. So if I jump back, right, you can see this favorite button was disabled. When I go back here, but you can kind of jump to different pieces based on this or question.
How do you get the actual context like that being done for you with?
So with the framework, but I'll show you that. Yeah, it's done by the framework, but the way I configured that was simply through it was just simply through. So here's where your definition of actions like looks in. That's all it looks like. It's just I threw it into a string. It's just kind of a convenient way to. It's like a trick you can fix here. And then I kind of like use some TypeScript to kind of like put some type writing around it, so you get some like nice auto completion. If you're using VS Code or something. This way. Yeah, exactly. That's a good point. So remember, Redux doesn't observe basically. So whatever, like React's much more opinionated so like you can catch your errors on specific ones. Is the error code for this one? Those are all things that your side effects have to involved, but then your side effects also have to be so those errors Any further questions? Is this all making sense? It's like a lot to handle, but I mean, once you get the hang of it, it's super simple, right? I'm going to post links to this stuff too, so you can kind of play with it. Okay, so is Redux for me? So like you're working on an application, and you're wondering, is Redux for me? Should I go with this pattern, right? And just go back to the graph. If you anticipate this kind of spaghetti situation happening, or if it's happening, you need to do some refactoring. Redux probably might be for you. Like it just kind of asks yourself the question, like, can you anticipate? And like, kind of the big indicators, like, are you working on dashboard, like an interactive dashboard with lots of different component changes handling at the same time? Okay, that's kind of where the use case is, like our workflow software. This is a little bit more of my opinion. you can have people in the React community who debate this and might post blogs about, like Dan Abramov, I think that's his last name. Yeah, thank you. He's like a React co-author, or Redux author, whatever. He's like kind of the thought master. Even he publishes an article saying you probably don't need Redux author. I don't know. So you can kind of search those blog posts and see what fits for you. My personal opinion, if you're making a React single-page application of moderate to high complexity, I frankly use Redux every time. Like, it just, we've done it for the past year, and it's scaled very well. I mean, you can ask it to, like Jason and Greg, they've been on the project, you can ask it their opinion as well, but Redux has scaled very well with our application of high complexity. That's what I'd recommend. Like, you can, again, the React world, you can dig into philosophy and blog posts all you want. I'm trying to give you a simple rule to follow. You don't have the time for that. But that's kind of my recommendation. Angular users, really, I'd only recommend this for like highly interactive apps. So like complex dashboards. If you're just doing like data entry, stick with services. Just because I think the onboarding and the amount of boilerplate you use for Redux doesn't really make it worth it. And keep in mind it does have drawbacks. So with Redux, it's kind of all or nothing. You can kind of scope it to an Angular level to a module. That module is like pretty isolated. But it's kind of all or nothing, right? You don't want to like mix like kind of other like global state management systems with Redux. I think it will get kind of messy. It's hard to build a monolith in several Redux sub-apps. So I think the client we're working with, their idea, like, we in Chicago, we're developing workflow software. There's an offshore team that's developing other apps. There's San Francisco team, like their own team that's developing other apps. And I think the vision for them is merging this all into a monolith. Well, guess what? Some of them aren't using Redux. Some of them aren't. You might have conflicts with action names. You might bundle several different side effect libraries unnecessarily. That's a consideration. Cleaning up old state's hard to remember. We're not, like, you're storing the state globally, and it persists. Angular, at least if you use services, you can scope it to the component or module level. If you don't want to like really application singletons. Redux is essentially the application singleton. Think about processing states. You fire off a success action, right? And you have like a little label saying like loading success, right? And you reload the component. You want that state to be clear. You don't want to show success action, right? But because that existed in Redux, or maybe like an error still existed in Redux before, it was never cleaned up in the previous React. That's something you need to consider too. I think there's a lot of boilerplate. There's a lot of training that needs to go with Redux initially, and then finally, some limitations in your library. You might have to store pieces of state, like loading statuses, that only one or two components of that application care about. So I want to thank you for coming to this talk. My website's up there. Google me on LinkedIn, ask me questions. I'd be happy to answer them. Anything about front-end development, my time at West Monroe, whatever. I'll be here after the talk. And thank you guys for really.
Is Matthew here? Right, cool. All right, so go ahead and get set up, and yeah, I think I could right. I think we do Q&A, but I think John is done. He's had a tough talk.
Array would be the stickers. The t-shirts are color-coded by the ribbon that surrounds them, so there's a little legend there that says, hey, given this color, this is the size you're getting. And they're not 180 of them, so move fast.
All right, we're getting settled back down. Let's wrap it up. We got one more talk. So it's only some pretty interesting distributed database stuff. It's Matthew Vall.
Yes.
Okay, very good.
All right. So I'm with AngularDB. It's a multi-model database. And I'm not going to tell you anything about it, other than I'm going to tell you that given that this is really a JavaScript group, our guy who's our JavaScript expert is in Germany, and, well, he didn't fly out for this. I'm sorry. But I will tell you that we have something called Fox services that I'm not an expert in that allow you to run native JavaScript services right on our database server to get some very high yield services running in your JavaScript language. I encourage you to look at that and not to ask any questions about it. It is free to download to run on one server or many, on your laptop or a distributed setup. So what I'm going to talk to you about is the computer science behind having a distributed database, which to me, when two of my former colleagues came and asked me to join their distributed database company, I wasn't sure that was going to be much of excitement or what have you. I've learned that's not true. In fact, as a personal experience, I don't know about y'all, but when I was in high school, I took calculus. When I went and was a freshman in college, I had to take engineering calculus. And as you can tell, I'm an old fart. So it took 30 years before I ever found one use for calculus. But it was in distributed database in the last few years. And so all I'm going to do today is not tell you about how great our database is, but just to tell you these are some of the nifty things you get to do, and I'm not going to tell you about calculus. Now, it's almost like the first presentation leading up to me, because we have this really nifty thing called Raft. And what Raft does, we didn't come up with it. It is a consistency and resiliency protocol that we have to use in a distributed database. Why? We need state. Remember, y'all were just talking about state. In fact, I would guess that they may even use Raft or one of the other protocols. What it does is it allows us to have multiple servers tracking the state, and they stay in sync. So that if there's network outages, if we have drops in packets between the servers, just fails and it comes back, oh, that's really bad. The machine fails, it comes back with old data, or hell, you lose a whole rack. I've never actually seen a whole rack die, but I'm sure it's possible. All right, so how do you manage these situations to keep your state consistent and running at all times? That means you need to have either a consensus algorithm, where the first one is usually taught in college is called Paxos, which says this is how you have all of your servers talk to each other and then achieve a common Zen-like state. It's very complex, very hard to do. And so somebody else in the last 5 years, to 2013, came up with a simplification protocol called Raft, and it's very simple, and it's very useful. It only has 3 components. I want to kind of walk you through this. I'm not just describing stuff to you, describing problems. I want you to walk you through it. You have a state machine, exactly like what you had in this discussion that we're doing, right? You end up with a state. Somehow you're going to get there. And how do they give you the state? In fact, how did you see him doing edits of the state? Is you have a log. But that log of actions has to be replicated and agreed to across all of these distributed servers who are giving you the resiliency of your state. And along the line, Raft's simplification to all of this is what's called a leader election. So I'm just going to walk through this. You've actually just seen some of it in this demo before me. So let's talk through it. All right, what I really need, I have a distributed cluster of machines. What machines are operating right now? So this is actually an important state. What are my active servers? I have 3 of them. One of them's in Boston in rack 2, location 20. By 20, that means where their rack position is, up and down the rack. There we go. Another one's in 25. A third one's in 44. This is my state. This is all I really need to know. But I do have a a node tree that has this information in it. But the information is actually stored across the distributed servers as a series of actions. And this is the replicated log. Every time a server comes online, we add to the active server file its name, kind of a key value store, or say up an array. And when someone says, hey, the server's here, or the server announces itself, the leader, we'll talk how we get a leader in a minute, it says, okay, all of the followers to our Raft state, here's the next log entry. We're going to keep everything in logs. And if the majority come back and say, yes, we have logged it, and then the leader says, then we accept this, and it is now a truism. It is now real. And so for every change of a server coming up or a server going down, it comes to the leader. The leader shares it to each one of the followers. The followers say, yes, I have it. It's committed. And so this is what Raft does. It allows you to have a distributed state that is resilient. The last thing I don't have a slide for is cool and easy, an election. How do we get a leader? When the servers first come up, they look around. Are there any other servers here? Yes. Okay. Do we have a quorum? Do we talk to each other? Do we have a quorum? Yes, we now have at least a quorum of whatever is our minimum. So if you have a 3-server, that we call an agency, you have to have at least 2 to have quorum. As soon as you have 2, coolness. All right? They then wait a random amount of time and say, I want to be the leader. And as long as 2 people don't raise their hands simultaneously, everyone else says, okay, I haven't said I was going to be the leader, you be the leader. Now, if 2 of them say I want to be the leader at the same time, they both have to back away. They wait a random amount of time. One of them says I want to be the leader. Actually, that resolves real fast. And so the advantage here now is we have a very simple piece of code to elect the leader. Then the leader runs the show, but he's sending pings out to the followers. Now, the ping could include one of these actions to change the replicated log, or it could be a replicated log entry that has nothing in it. But he's at least telling the followers, I'm here. If any followers doesn't see the leader after X amount of time, they start an election again. First one says, I want to be the leader. And even if the leader is still alive, if someone says, I want to be the leader, he has to abdicate immediately. And this is how we keep a quorum of machines up and running to have state. Now, I don't know if Redux has a distributed component to it, but if it did, this is exactly how it would work. Because you just saw it there. They had a log of entries, and if you had a leader who has been making sure we have everyone else at the same state, boom, you now have consensus. Go ahead.
Is this state, are these actions?
These are actions that lead to the state.
But are these like sort of the actions that are in the, is this the data in the database, or is this the state about the database?
Okay, what this is this is a log of changes to our state. And we never summarize it. We actually, on every one of the agents who are managing our state, they keep the log all the time. So that if all 3 of them happen to go up and down real fast or for a wild amount of time, they look at each other's logs and resolve who's got the most thorough log, and then they they'll actually replicate that whole log over to the other agents to get a consistent state history across all of them. State of the cluster. Okay. Now, this is called the agency in the AngularDB product. Believe it or not, you as programmers, if you had your own state, okay, this Redux thing sounded good. Okay, I'm not knocking it. But if you needed a consistent state, you can actually use our API and put it into your own little node tree. And we'll keep it for you. And we'll make sure the leader takes it, gets out to the form of the followers. If the leader goes away, you've got a follower who comes up, still has your state. It's almost like Zookeeper, but just small. All right? And it sounds like it could be like Redux, but it's not supported by all the nifty tools that program has. But it is distributed and resilient. This is cool stuff. So we actually had to write one of our own. It had some bugs in it. I haven't fixed the bug in our Raft code in, 72 hours. But it's nifty. Now, another thing that's coming up in the world of distributed servers, this is probably happening everywhere. Something called log structured merge trees, LSM trees. Google published their level DB code, which I think some JavaScript libraries use. Facebook went out and kind of rewrote it to their specifications and called it Rxjs. You may have heard of it. Exact same thing. Some folks have taken this whole tree storage idea and put it underneath MySQL. And there's probably 2 or 3 other databases, including AngularJS, NuoDB, I've gotten another one. They're using this as their way of doing storage. Historically, for a database, you would use a binary tree kind of index over here, data blobs over here. There's a lot of rewriting stuff all over the place. What a LSM tree does is it says, we're just going to write everything once, keep it in a chunk, and start moving chunks and combining what they call compacting chunks every now and then. So let me show you what a chunk looks like. All right. While this says a tree, let's just go to where we are in a database world. We're going to make a file out of this. All right? The file is going to have 1 or more blocks of data. Each of these blocks, which is one of these little blue sections here, is going to have many keys or many key value pairs. Here's my key, here's the value. Be a binary value, be a JSON document, I don't care what it is. Binary blob. Also, at the end of the block is a partial index. Why partial? Well, whatever computer scientists came up with this structure basically said, once we're down inside of a block, which can be around 4,000 bytes in the basic implementations, we can start, these are all here linearly. So do we really need to have a full binary index to every value there? No, we just need some start points. Like here's where the beginning is. Oh, about halfway through is key 4, and that's here. Oh, and by the way, here's toward the end, key 7. So there's a partial index. So once you've gotten yourself narrowed down to my data is in this block, you're either searching it linearly or you're finding a jump point into it and searching that area linearly. Okay? And then these blocks are not a fixed byte size. If I say this is a 4K block factor, that means 4K is your threshold. Once you get a total of more than 4K of keys and values, then you'll write your index still in the same block and move on and start a new one. These are not fixed block sizes like you might have seen in computer science. And so we'll write all of these in sorted order into this log file structure. And at the very end, we have an index that tells us the first key in each of our, actually it says the last key, but that's a whole different problem. It says what the last key is in each of the blocks. So you can go see, hey, this is where I need to go find my key.
Can you explain the partial index?
Yes. This is the first time I've given this speech, so my words may not be great, so I'll try to do better this time. What we want is, we want to be able to, we know that this is a small chunk of memory. And in a small chunk of memory, a linear search is not bad. So all we really want to do is cut down how much of a linear search we're going to do. So if we know that what we want is key 6, we will quickly come here and say, key 6 is greater than key 4, but it's less than key 7. Jump to key 4 and linear search from there. And that's all the partial index is doing. It's helping you do a little bit less searching in there, but it's still going to be a linear search. All right? And again, we're not indexing the whole section. Right? This is just getting us to the block. This is getting us to a portion inside the block. Yes. Okay. So in a database today, what we're doing is we're making bunches of these files. Bunches and bunches and bunches of these files. And so now let's go to a more macro view when you do a write into our database, or Rxjs, or one of the other people who use the same technology, you're going to come in and you're going to write into basically a binary buffer of some kind that sorts it when you write it in. It's going into memory. Now, in case your program crashes right around then, there's also a recovery log that's a secondary restore point. But we're going to write this into memory and keep it in sorted order in memory until we reach the threshold of how big we want this write buffer to be. I'm going to pick a number out of the air, call it 60 megs. At 60 megs, we start a whole new write buffer to start storing things, and we set this one, the previous one, off to the side. It's still in memory, but then we start writing it out in sorted order, just like we see here. And that old write buffer goes from memory to disk, and it becomes this in a non-changeable file. It's a read-only file the moment it goes to disk. Now, Google started off with the term level DB because they do all of these files in levels. All right, let's say you're streaming in a whole bunch of random data. What's going to happen is every time you fill up this 60 meg buffer, it's going to pop it over here and start a new one. You keep filling it up. He's going to write that down to one file at this level, and he's going to just keep making new files down there. So if you have to go look for any of that data you've recently written, you have to first look here. You have to then look here. And for every one of the files that was written in level 0, you have to go look through them again because those files overlap each other in sorted order. It could be in any one of those. Then comes a step called compaction. Compaction is where we take all of these files that are not sorted and are all at the same level, and we make them into the same size files, but chunked in sorted order at the next level. I'm going to skip level 1. Let's go to level 2. We have sorted. So we went from multiple unsorted files, unsorted related to each other. They're sorted within themselves. So we do a merge sort, and we take those, chunk them out into the exact same format, but relative to each other, they no longer have overlapping keys. So we've now got one level, we're going to call this one level 2, where every single file is unique into the portion of the key space it covers. So that when you go and do your read, yes, you still have to read there, yes, you have to read there, yes, you have to read however many are in this level. But when you get to this level, they're non-overlapping. There's only one that you have to go look at. And over time, there are reasons that will, you'll do the same thing over time. That if you flow enough data out of 0 and 1 to 2, you may choose to then compact some of its stuff into a level 3 or more. I won't go into those rules. But the whole idea is, I always think of it as like key space. If I look from A to Z, I have a whole bunch of A to Z files in level 0. But once I get to level 1, I only have chunks, A to F, G to M, N to P, and all the other levels. So I have only one place to look. That's what this new file format does. It has a couple of tricks that can bite you if you don't know about it. You never go and edit a record that's at one of these other levels. If you have the same key and you make one edit to that record, you write it brand new. And that's why the system has to look all through these to find the most recent one, most recent instance of that key. That also implies that if you want to go delete all your keys, you don't actually delete anything. You're about to go write a whole bunch of records that, again, have your key, but instead of your value, it has a little flag that says, this key is hereby considered deleted. So all it's really doing is becoming a tombstone, let's say at level 0, that hides the fact that you have that key again at level 2. So we have to process these in order because there's also a implied history. And so that's how that works. And so that we have the problem in our database and these other people who use this technology. Someone says, I deleted all my keys, but I have more disk space in use now. Yeah, made a couple of them. There are fixes to that, but that's not our discussion here. All right, so this is a cool technology. It's coming out. You're going to, whether you know it or not, you've probably already been impacted by it. And if nothing else, remember, the leaks can kill you. Okay, another cool technology. Never even heard of this. It's called a bloom filter. And of course, I ran into the bloom filter related to the LSM trees. Let me go back to my one little slide here. See here I called out metadata? Well, turns out Google hid a bloom filter right there. What's a bloom filter? Now this is actually cool and you may have a use for it someplace else. Not today, hopefully before 30 years, but you know, sometime in the future. If you have a collection of data that is static, a bunch of keys, which by the way, we've said these LSM trees are static, right? Once they're written, they're there. What you do, a bloom filter is a way to say, what's the probability that my key is actually in that data without having to go and retrieve it off the disk? So you don't want to have to go and look, grab that block, and hunt through it to find out, oh, the key's not really here. Bummer. Okay? This is what a bloom filter does for you. Bloom filter has this rule. It will absolutely positively never tell you that a key's not there, but it is. However, depending on how you want to set the probabilities, it can say, yes, I think your key is in here. It's actually not. All right, that's called the false positive. All right, and so before I kind of talk through most of this, so how are we going to do this? The basic methodology is there are tables published where you say, what's the probability that I'll accept of a false positive? LevelDB, Rxjs say 1%. You ask for this key 100 times, 1% of the time you're going to get a false positive. You're going to go, oh, I should go read it, and it's not there. Different company I worked for, we had that set down to 0.04%. We had a lot of reads that we really just didn't want to miss. Once you have that, you get two numbers that come back. One that says, for every key, you're going to have to allocate X number of bits, and when you fill the filter, you're going to fill Y number of bits. Actually, I think this is K and this is M in the papers, but I'd have to go look at it. Then you're actually going to go allocate a bit array to have the number of bits that you learned up here times the number of keys that are in your static list. Okay, number of bits, not bytes, but bits. And then for each key, you're going to take the key, and I'll show you the formulas in a moment, hash it, and use the hashes to say, okay, I have 30 keys, so I have to have, I'm going to pick a random number here, 300 bits. For this key, I need to set this bit, this bit, this bit, and this bit. And for the next key, I need to set this bit, this bit, this bit, this bit, this bit. All right, so it almost looks like a random pattern of the bits. But what happens is you can later come back with your key that you want to read and do the same pattern and say, do I happen to match all of those bits? If the answer is every one of those bits matched in the filter that you wrote, it's in there with a probable false positive. If not every one of those bits matches, it's not in there, guaranteed. Go somewhere else. And while this all sounds complex, as long as you can copy the code, it's written somewhere else. Okay? I mean, I'll kind of describe it to you, and that doesn't mean you should memorize it or walk out of here saying, oh, that looks too complex. No, because I didn't write this code. I copied it. In fact, here's a paper. Okay? And by the way, the interesting thing about this is this was a footnote in Google's implementation. And if you go look at Google's implementation, they didn't do that. I haven't ever found somebody at Google that I can ask, why does it say you did it this way and you didn't? Now, what you're seeing here is what was said, and because, well, we have a guess. We guessed that Google originally did this for their Android system, which is, used to be a really small processor, and they simplified this to have less IOPS. And that, since we were running on servers, we said, screw that, we need to get it accurate. And so we went back to the original paper. If you have an array of keys, take one key at a time, get one hash. This is a very simple hash like a XOR, all the bits of the key. This is a more complex hash, something called a murmur hash. So look it up. Don't ask me. I just copied it. Do the same thing with your keys. You have now two hashes. We'll come back to this line. For the number of bits that are defined, remember I said you had to get 2 bits. One is how wide is this pre-allocated array. The other is how many are you going to set in random places. So for the number of bits that we're going to do, here's my iterator. I'm going to go through and I'm going to take my first hash and I'm going to add to it j plus 1 times the second hash. Okay? And from that number, I will divide it by, and this is, just call that the size of the array. All right? We don't need to go into that. By the size of the array. So I now have a position in the array that this formula just randomly picked for me. But it does it in such a way we can reproduce this every time we give the same key. Now, for the next iteration to go to my next bit, I take my first hash, okay, and this is where we're actually setting that random bit. And I take my first hash, and I'm supposed to add this delta, which is a formula someone came up and said, you basically want to rotate right by 17 bits and add that to your first hash so that your hash is randomized for the next time coming around through the loop. Not randomized because it's deterministic, right? So it's not random. But it works. All right? And I have cacti graphs, or which would be that same as Grafana or whatever now. It would sit there, and we get standard reports of how often I was getting false positives out of my system under every data load, locked in at 0.04% all the time. This thing is really accurate. Okay? And so this is how, when you have all of these bunches of trees that I was talking about, we may have 5 or 6 files here. We only have 1 per level, but we may have multiple levels. Instead of going and hunting out old records in those files, I go and hit their metadata, which is what I keep in RAM, which is their blue book. It's cool. Never knew about this. Here's an interesting. Now, moving on. Just remember, this is Matthew's trying to show you nifty stuff, right? A hybrid logical clock. In a distributed system, particularly if you are doing transactions, we need to say, take this money out of this person's bank account and add it to this other bank account, and both of these have to post at the same time, not, maybe one and definitely the other. Which is, by the way, how one of the Bitcoin farms died. They didn't have that. It is. This thing called a hybrid logical clock allows us to show, unless you have atomic clocks. All right? And you don't have atomic clocks that are backing in your AWS servers or your Google Compute servers or whatever the hell you're using. And NTP, which is good, in reality, it's anywhere from 6 milliseconds to 40 milliseconds off on every server. It's just a window. It's there. And so some other guy, not me, somebody came up and said, okay, to be able to do these distributed transactions, to show causality, or to even just show progress across the network, how can we have a timestamp that works? And these guys came up with something really simple. And I mean that. It's one of those deals that's so useful, it's so simple, and it's really useful. we are going to assume that NTP clocks are at least close. All right? If you got servers that are multi-minutes off and all of that, you can argue that this isn't working. All right? We're going to say they are close. Remember we said 40 milliseconds, maybe? That's reasonable. So we can take a standard timestamp like you get in Unix, which is 64 bits wide. That's 8 bytes. The top 4 bytes are seconds. The bottom 4 bytes are down to nanoseconds. Not that they have that resolution, but that's how much it's covering. So those bottom 4 bytes, we're going to strip out the 16 that are at the bottom. They're supposed to be nanoseconds, and we're going to make that something else. We're only keeping 48 bits of precision off this nanosecond timestamp because we know that once we strip it out into 48 bits, we're only in milliseconds, and we've already said we only need millisecond resolution for NTP. Now, this timestamp we're going to start throwing around with all of our messages. The rule is very simple. Everyone who gets the timestamp makes a new one for the next step in the process, the next person in the chain. And the next one is one of two things. As your NTP clock giving you a number that's bigger than the top 48 bits? If so, use your NTP clock and set the bottom 16 to 0. Easy rule. If your NTP clock is still the same as these 48 bits, increment the bottom 16. And now, if you think about that's those 16 bits, or that's 65,000, blah, 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 blah. And the paper guy says, we've never seen it get more than single digits into the count at the bottom. All right? So it's sufficient. So if your messaging clocks are always producing the next timestamp off that rule of either my NTP clock or the highest I have seen come across the wire, all of these guys are slowly keeping themselves in sync. And there's enough time. Yeah, so one guy's running a little faster all the time than these guys. We're in milliseconds. It's network. They're going to come together. It's never like you're going to have a runaway problem. So, you have a deal where you're trying to show causal or relationships happening between servers. The clocks aren't exactly what you need. This is what you do. Okay? Going to use it today? Probably not. Might you need it sometime? Yeah. You know what it is? You kind of got the name for it? Google it. That's all I want to do. I want to share with y'all. Let you know.
Are you going to be posting your slides also?
What?
Your slides?
What about it?
Are you going to be posting them?
Oh, well, yes. Yes. How do we?
All right.
I mean, we post them on our site for presentations. I guess I sent you the link.
Yeah, well, a good thing to do is to post as a comment to the meetup, so that everyone who is RSVP will then get the notice for that.
Got it.
All right, cool. Thank you.
Take off.
All right. Good night. Thanks for coming out. I don't think we have anything lined up for next month yet. I mean, Jennifer might have some things in the pipeline, but I don't think it's on Meetup yet. And we're always looking for people who have interesting stuff, and it doesn't have to be the super advanced, super sciencey stuff. It's great. It's good to review that sometimes, but I mean, we also should circle back to beginner topics sometimes. So even if you're a little bit newer, just explaining a basic concept that we help with somebody else. As always, Redux and fancy new technologies are good, but anything you're interested in, and if anybody actually would like to help us out, that'd be great too. It's always good to increase the bus factor on organizers to make sure we're keeping covered. All right. Good night.
Thank you. Hey, I would love to know that.
Cool. Yeah, I mean, it's pretty much just, actually, let me shut down the recording here.